Continuing with page 3. First problem after example 6 on page 390. Find where the tangent of the curve y equals x cubed at the point where x equals 2 meets the curve again. Okay, so remember that y equals x cubed looks kind of like this. Okay, it goes through the origin, goes down here, goes up here. So it says at x equals 2, there's a tangent. I'll use blue. And I guess it crosses at x equals 2. And I guess it eventually crosses again, maybe down here or something. Okay, so the first thing we need to do is find the equation for the tangent of the curve. And the hardest thing to find is the gradient. So let's find the gradient of this blue line. To find the gradient, we take the derivative of y equals x cubed. We get y equals 3x squared. We want to know what exactly the gradient is of the blue line that goes through the point 2 comma something. 2 comma something. We don't know what the y is yet. It doesn't matter because we don't need it to find the gradient. It doesn't matter yet. So x equals 2. So we just put the 2 in for the x, and we put in 3 to the 2 squared equals 3 times 4, which is 12. So the gradient of this blue line is 12. What point does it go through? To find out which point it goes through, we can use the y equals x cubed equation, and we plug in 2 again, and this time we're going to get the y value, which is going to be 8. 2 cubed is 8. So the point here is 2 comma 8. So it goes through 2 comma 8, and it has slope 12. So remember the gradient, what do you call it? The point slope form or the point gradient form. It looks kind of like this. Oh, I'm sorry, not prime, not dash. It's like y minus y1, x minus x1, something like that. Okay? So we know that 12 is m, and we know that 8 is y1, and we know that 2 is x1. So we could just write that out now. We have y minus 8 equals 12 times x minus 2. Okay. And now we just need to check when it meets x equals 2. I'm sorry, where it meets the line again, or the x cubed function again. So the way we can do that is we see when is this equation the same as this equation. Easiest way to do that, if we are not using the calculator, is to put the y on the left, put everything else on the right. Let's see, that's going to be 12x minus 24 plus 8. So it's going to be 12x minus 16. Okay, something like that. And then we can set these two equal to each other. We can set x cubed equal to 12x minus 16. And then we put x cubed minus 12x plus 16 equals 0. Now, according to the book, you can factor this. We don't normally know how to factor cubic functions, but in this case, we kind of already know one of the roots. It's 2, right? 2 is a solution. So we know that some of the binomials that multiply out to get this is x minus 2. Actually, there's 2 roots at 2. That's why it like touches there. It doesn't cross it. So actually you can like factor out x minus 2 quantity squared, and then you're left with something else, but I think that's kind of like over our heads. So let's do this. We're going to solve this quadratic using polysmlt. We'll go into apps, and then we'll go into polysmlt, and then we'll press any key, and then we're going into polyroot finder, and we are in a third order equation because it's a cubic. And then we go next. And then we're going to give it all the coefficients. The first coefficient is an invisible 1 here. The second coefficient is, there's an x squared term that is not there, so that is an invisible 0. Then there's negative 12. And then there is a 16. And we'll say solve. So the three roots are negative 4, 2, and 2. 2 squared x minus 4, or x minus x plus 4, actually. So, like, one of the roots is x equals negative 4, and that would be this point here, right? And they ask where it meets, so they kind of want to know the y value too. To find the y value, you just put it into y equals x cubed, or you could put it into the linear equation here. This equation, either one. So x cubed, negative 4 squared is going to be positive 16, and then multiply times negative 4, and then we get negative 64. Okay. So the coordinates are negative 4 and negative 64. Okay, that was challenging. Okay, let's do 12. Consider the function f of x equals x squared plus 4 divided by x squared. Find the derivative. Now, just to make it easier, we're going to write the power in the numerator. So we do that. And then we're going to figure out when is the tangent to the curve horizontal, which means when is the gradient 0. So let's see, we're going to solve for x squared plus 4. Oh, I'm sorry, I didn't take the derivative yet. Got to take the derivative first. So I'm going to take the derivative of that. It's going to be 2x minus 8x to the negative 3, right? All right, now I'm going to check when is the derivative, which is 2x minus 8x to the negative 3, when is that equal to 0? Okay, so okay, we don't know how to factor things that have x in the denominator, so let's multiply everything by x cubed so we don't have anything in the denominator. So we're going to multiply the left by x cubed, we're going to multiply the right by x cubed. Of course, the right is 0, so even if you multiply 0 by x cubed, it's still 0. So we're going to get 2x to the 4th minus 8, because we multiplied both terms by x cubed, and the right side is still going to be 0. So let's solve for x now. Even though it's an x to the 4th, it's not that hard because there's no other terms. So we'll add 8 to both sides. Then we divide both sides by 2. And then we take the square root of 4, we get 2. We take the square root of 2, and we get square root of 2. So what do we multiply times together? 4 times to get 4. Plus or minus square root of 2. Okay, so that is the solution to when is the slope, or when is the gradient of this function horizontal? X equals plus or minus 2. Then it says, show that the tangents at these points are the same line. Okay, we know that both of the tangents at this, I mean, what they're talking about is like maybe you got something like this, and it's like, oh, I'm going to draw a tangent to this point. I'm going to draw a tangent to this point. You see how it's the same line? They're like at the same level. So we already know that the tangents both have a gradient of 0, so, okay, it has a chance of being the same line. The only other thing we need to figure out is if they're both at the same height. So, let's see. We just found out what these 2 points are, right? So let's plug the plus and minus square root of 2 into the original equation, and that's going to give us the y height. The y height, right? So we'll get, first we're going to do plus square root of 2. So we'll have 2 plus 4 times, let's see, square root of 2 squared, square root of 2 squared gives us 2 in the denominator. So 2 plus 2 is 4. Okay, so for square root of 2, positive square root of 2, the height is 4. What about for negative square root of 2? For negative square root of 2, we're going to get y equals also 2 plus 4 and also 2, which is also 4. So they're both at the same height. Okay, so both at the same height, or y value, okay, and same gradient. Okay. Number 14. Find the equation of the tangent to this function at the point x equals a. Find the equation of the tangent. So first thing we need to do is we need to find the derivative. So it's 2x minus 1 at the point where x equals a. Okay, so at the point where x equals a means that we're going to put a in for x, and we're going to get 2a minus 1. That's the new gradient. Okay, so now I'm going to write the equation for my line, which is y minus my y coordinate. And the y coordinate, let's see, we know the x coordinate is a. How do we get the y coordinate? We simply put a into this y equation here. So we get a squared minus a plus 9. So it's y minus a squared minus a plus 9. And that is equal to the slope, which is 2a minus 1, 2a minus 1, times x minus the a. Okay, so that is the equation of the line, which goes through the point a, or x equals a, and the y coordinate is this mess here. Okay, can we simplify that a little bit? Let's try. So we'll have 2a x minus x plus or minus 2a squared plus a. Does that look better? Not really. Let's see if we can get rid of something, because now we have negative a squared plus a minus 9. Let's see. Can we get rid of something? We have a on both sides, so we can get rid of that. We have, I think the rest of it we're stuck with. So we put y equals 2a minus 1x. 2a minus 1x. Let's say we have 2a squared here, and we have negative 2a squared here, and minus a squared here, so we can add a squared to both sides, and we get negative a squared plus 9. Okay, so that's our simplified equation for the line of the tangent. Okay, Then it says, find the equation of the two tangents from 0, 0 to the curve. So if we know that the like this is any tangent to any point on our parabola, so it could be this one too, where we have a 0, 0. So we could put 0, 0 into the equation, and we can solve for A in the case of this special tangent that goes from 0, 0. I drew a picture here. You have a parabola in red, and then you have two tangent lines going through the origin that are touching at two different points. So we're trying to find those 2 points that it touches at. We know the general equation for the blue lines. And how are we going to find the specific equation? We're going to substitute in x equals 0, y equals 0. So we're going to have 0, 0 equals 0 minus a squared plus 9. So that means a is equal to plus or minus 3. If you do a little algebra there, you subtract a squared to the left side, then you're going to have a squared equals 9. So a is equal to plus or minus 3. So those are the two solutions for these two blue lines here. So all we need to do now is to substitute the positive 3 and the negative 3 into the equation, into this equation, in for a. So a equals positive 3 first. And so now we'll have y equals 2 times 3, which is 6 minus 1, 5x, and a 3 squared is 9. We'd have minus 9 plus 9, and yeah, and that's it. Okay? And then the other one would be a equals negative 3. So it'd be y equals 2 times negative 3, which would be negative 6, minus 1, which is negative 7, x, and a equals negative 3. We're going to put negative 3 into a squared. It's going to be negative 9 plus 9 also, and that's it. So one of our equations is negative 7x. The other one is positive 5x. Just to make a little space for b and c, I've put my coordinates here, and then I've put the equations of lines here that correspond to A. I don't think I've ever done this before on a solution, but I am going to remove these two from your assignment because it takes up a lot of space, and I think these are probably the problems that maybe are HL problems. I'm not sure. They seem kind of hard. Okay, so I did B here, but you can ignore B, just do A. Alright? Let's go on to 15. Find the equation of a tangent to y equals e to the x at the point where x equals a. Okay, so the graph kind of looks like this. Okay, x is a. So let's say x is a is here. This is the graph of e to the x, and so this point here would be e to the a. Find the equation of the tangent to e to the x at the point where x equals a. So, it's that. Okay. Hence, find the equation of the tangent to y equals e to the x. Find the equation of the tangent to y equals e, which passes through the origin. Oh, this almost goes through the origin the way I drew it. So it goes something like that. It goes through the origin. Okay. Alright. So this point here is a comma e to the a, right? And this point here is the 0, 0. And let's find the equation of the tangent line. The equation of the tangent line is in this form, right? Y minus y1 equals m times x minus x1. M being the derivative of y equals e to the x. Y prime equals e to the x. The derivative of e to the x is just e to the x. Evaluated at point A. So it's e to the a. Oh, it's also e to the a. So let's remove the m and we'll put e to the a, which is the gradient. And then the x value is going to be a, right? And the y value is going to be e to the a. Okay. Okay, and then it says, find the equation of the tangent which passes through the origin. So since we know that it passed through the origin, that means one of the possible points is 0 and 0. And so we can find out what the a is, which would make that true. And we can do that by doing, let's see, negative e to the a equals e to the a, times x. X is 0. So you just multiply times negative a, negative e to the a. So the negatives kind of cancel out. The e to the a's cancel out. What are we left with? We're just left with a equals 1. So that point is 1, a equal 1. So find the equation of the tangent line. The equation of the tangent line is this one, right? But we're just going to substitute a equals 1. So it would be 1 minus e equals e times x minus 1. That would be the tangent line. Okay. Okay, here we have an interesting graph. We have a quadratic, green, and we have a log function in black, and they touch exactly at this point. Okay, and it says, since they touch, show that the x-coordinate of the point of contact is b, explain why ab squared equals log b, blah, blah, blah. Okay, so they named this inner contact point b, and we're going to figure out why this being called b implies these two relationships here. Basically, to do this, we need to figure out a couple of things that maybe are not so obvious. One is that if these two curves touch at exactly one point, that means that they share a tangent line, which goes like right through the middle of them. Okay, that blue line there. Okay, and if they share a tangent line, that means that they both have the same slope at that point. Okay, so let's try to figure out the slopes of each of these curves at the point x equals b. Okay, so to do that, we need to take the derivative. So the derivative of log x is 1 over x. The derivative of ax squared is 2ax. Those are the two derivatives. And it's at point B. So 2ax evaluated at point B is 2ab. The derivative 1x evaluated at point B is 1 over b. So these two things are equal to each other because the gradients of the two curves are equal at that point, right? Okay, so we know that 2ab equals 1 over b. The other thing we know is their heights are equal at that point. So like y equals log b, y equals log x at that point is log b. And the height of the green line at that point is y equals ab squared. ab squared. So log of b equals ab squared. What do you know? That's the two things that we were trying to prove. Log of b equals ab squared and 2ab equals 1 over b. Okay, let's move on to the next thing. The next thing says, deduce that the point of contact is square root of e, comma, 1/2. Okay, so now that we have two equations and two unknowns, which are these two, we can solve for what a and b are. And once we know b, b is the x-coordinate of this thing. So, I see an AB here, I see an AB here, I see a B here. If we multiply the b here, then we're going to get b squared. We'll have ab squared. It looks exactly like that. So why don't we do that? So we're going to multiply b times both sides. We're going to get 2ab squared equals 1. And then we divide both sides by 2. We'll put the 2 over here. And now we have ab squared equals 1/2. Okay? And so now we can put that in for that. And so we're going to have log b equals 1/2. And let's take e to the log b and e to the 1/2, and then we get b equals e to the 1/2. So we know what b is. Let's just try to figure out what a is now using one of these equations. So, for example, let's try the equation 2ab squared equals 1. We know that b is e to the 1/2, so b squared is e. So we have 2ae equals 1. So So what's a equal to? It's equal to 1/2 divided by e. Okay, so that's what a is equal to. Now let's try to figure out what the y coordinate is for the b here. So to do that, we just put in b. We put b into either equation, either y equals ax squared or y equals log x. So let's try y equals ax squared. I'm sure you guys prefer squared to log. So and we know that a is 1 over 2e, and we know that x squared would be b squared, which is, we already know b. b is equal to e to the 1/2, so it's e to the 1/2 squared. So that's equal to e, and that's e divided by e, so the y value is 1/2. So there we go. That's where the 1/2 came from. And the b is e to the 1/2, so that's, it's b and then 1/2. Okay. C, find the value of a. Or we already did that. The value of a is 1 over 2e. Find the equation of the common tangent. Okay, we do know the slope of the common tangent. The slope of the common tangent turned out to be, let's see, was it this one? Yeah, it was 1 over b. 1 over b was the common tangent. The slope of the tangent was 1 over b. And b was e to the 1/2. So 1 over b is e to the negative 1/2. Okay, so that's the slope. We'll write it here. And then we'll put x minus blah, 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 y minus blah, blah, blah. The x minus blah, blah, blah part would be x minus, now we're finding the tangent line at this point, so the x point would be b, and the y point would be 1/2, so y minus 1/2 equals e to the negative 1/2 slope times x minus b. But just one thing, b is equal to e to the 1/2, right? So I'm going to substitute that. E to the 1/2. I was a little bit too close to box that answer. So I'm going to simplify the right side. E to the negative 1/2 x minus, and then e to the negative 1/2 times e to the 1/2 is simply e to the 0, which is 1. All numbers to the 0 power is 1, right? And then I have y minus 1/2 here, and then I can add 1/2 to both sides, and then here instead of negative 1 I'm going to have negative 1/2. Okay, now I can box the answer. So that would be the equation of the tangent. Ooh, we're done.